Okay, so we have y is equal to mx and then plus or minus b. And with that, we need to remember that m represents the slope of your equation. We've talked about that over and over and over again. Slope is going to be the coefficient that is paired with your x. Whatever is being added or subtracted, that individualized constant, plus or minus b. Sometimes it might be written in the back, sometimes it might be written in the front, but we know that that value is going to represent your y-intercept. Okay, now if we were given a, or an equation in what this is called standard form, and we'll talk more about standard form in just a moment, but this is an equation written in standard form. If we needed to rewrite it into slope-intercept form, we had to rewrite this into slope-intercept form, then what we would need to do is we would have to focus on getting y isolated. The whole idea of slope-intercept form is that y is isolated. So that means that we have to move our x term to the other side, and we have to then divide everything by the coefficient of our y term. Okay, so let's start with moving our x term. Okay, if I need to move a term, when I move a term to the other side, I do so by adding or subtracting. So let's write that step down. To move a term, you are going to either add or subtract. In order to move an entire term, you are going to add or subtract. So if I wanted to move 8x, I would subtract 8x on both sides of the equation. When I want to move an entire term, that means the number and the variable, I'm moving that whole term over, I'm going to use addition or subtraction. Because that 8x originally was a positive, we are going to use subtraction to move it to the other side, that inverse operation of its value. So that's why we subtract the 8x. So then when I'm rewriting this, I'm left with a positive 4y. And it's now equal to, I like to keep my x term in the front because I like to keep it in mx plus b format. So I'm going to write minus 8x. And then that 40 was positive, so I'm going to put plus 40. Okay, then I can navigate on to my second step. Step 2, I'm going to isolate y by dividing every term by y's coefficient. All right, so the coefficient that is in front of the y happens to be the 4. That means we're dividing every single term. Remember, this is my first term. That's going to get divided by the 4. This is a term, and the 40 is a term. Terms are separated by plus and minus signs. Terms are separated in an expression or an equation by plus and minus signs. So anytime that you see a plus sign or a minus sign, that's the start of a new term. Okay? So here, 4 divided by 4 is going to get y by itself. We now have y isolated, which is the goal. Negative 8 divided by 4, that's going to come out to a negative 2. So there's our slope. We have negative 2x. And then a positive 40 divided by 4 is going to come out to a negative 10. So we have a minus 10. So there's our equation. Y is equal to negative 2x minus 10. Negative 2 is going to be my slope. Oop, and I accidentally put minus when it should say plus. That plus 10, that's going to be my y-intercept. Okay, so now we can go ahead and move on to graphing it. Who can recall when we graph an equation that's in slope-intercept form, what is the first part that we have to graph? What is the first thing we have to graph, David? the y-intercept. So the very first thing that we're going to do is we are going to graph our y-intercept. So remember, this y-intercept, this 10, that's a point. That's at the point where x is equal to 0 and y is equal to a positive 10. So we're graphing the point 0, 10. I'm going to go ahead and move up so that we can see easier. And I'm so sorry, guys. I know that the camera is glitching a lot. Okay, so we're going to have 0 move all the way up to a positive 10. And that's where we're going to graph our first point. Let me see if I can fix this by moving here. Whoop. Trying to get this fixed to see. I can't wait for us to get our proper screens back. I think it froze. Yeah, it is. It's very glitchy. But, okay, we'll do the best that we can. All right, so we graphed our point 0, 10. Graphed our point 0, 10. Now we're going to go ahead and utilize that slope. Remember, slope acts like its direction. Okay, it's a GPS. It's telling us the movements that we're going to do. So if my slope is a -2, I can write it in two different ways. I can write it as -2 over a positive 1, which means that I would go down 2 spaces, but then I would move to the right 1 space. Or I could do the reverse. I can make this a positive 2, but then put it over a -1. Both of them come out to the exact same value. They come out to -2 as a whole number. If I were to go ahead and do positive 2, that would move upward 2 spots, and then the -1 would then have me moving to the left 1 spot. Okay, so that's how we utilize our direction. Okay, so from the 10, I'm going to go ahead, I'm going to go and do both directions just so I can show you this. I'm going to go down 2 and then to the right 1. And I'm going to do that a couple of times. Down 2 to the right 1, down 2 to the right 1 several times. And then I'm going to go ahead and do a couple of them going in the reverse, going up 2 and to the left 1. Up 2, left 1, up 2, left 1. I can only do that a couple times though. And then I'm going to go ahead and connect it. The reason I always connect it, I make it a continual graph, is because there is no context here. When no context is given, when in doubt, it's always continual. Okay, if context is given and it's describing data that's very specific points, that it can only be these specific values, that's when you would make it discrete, which is a dotted graph. Okay, and there's our graph. Okay, so again, this should just be some quick reminders for you guys. This shouldn't be anything brand new to you. We've been working on this for a long time now, so you want to make sure that you have a good understanding of that. Go ahead and flip it on over to the back. Hold on. Before you start going, oh my God, there's so many pages. Shh. Take a look. Quiet. Shh. Each page is its own problem. So I don't want you thinking, oh my God, we have so much work. Each page is its own problem. I wanted to make it large enough so it's easy for you guys to see the graph. Okay? So there is a method to my madness. Yes, I know that it's a lot of paper, but each page is a single problem. So you're not doing a ton of problems here. Each page is just one. Okay, so here we're going to start talking about what an x-intercept is. We've discussed what the y-intercept was. That was a point at which x was equal to 0 and that we crossed over the y-axis. So the x-intercept is just the reverse of that. Your x-intercept is going to be a coordinate as well, but it's when y is equal to 0 and you're crossing over the x-axis. X-intercept crosses or intercepts the x-axis. So let's go ahead and write that down. This is going to represent the x-coordinate. So remember, we always discuss it as a coordinate plane or as a point. So it's crossing the x-coordinate of the point where the graph I know, it's just, bear with the glitching. Where the graph crosses the x-axis. It'll fix. So again, that's when y is equal to 0. So you're going to have it where it's some value of x and then 0 for your y. That's what the point is going to essentially look like. So if I were to go ahead and draw a quick graph for you guys, like we said before, we already know that our y-intercept is a point where we cross the y-axis. That's our y-intercept. X is equal to 0. Your x-intercept is the point that you cross the x-axis. And that's when y is equal to 0. And then, of course, you can always have them connected together. Those 2 points connected together would create a line. I don't know why it's so glitchy. Let me see if I can pause it again. I think my thing was overloaded with cords. All right, so let's take a look here. With our example, you're going to have some problems that are a little bit more extensive, a little bit more difficult to being able to solve for your x-intercept, and then you're going to have easier ones to solve. We're going to first start with problems that are written currently in the slope-intercept form. So you need to make sure that you are going to state your intercepts. For a problem like this that's in slope-intercept form, we're going to first start off by stating our intercepts. So first things first, the easiest intercept to identify is going to be your y-intercept, right? Because we know the y-intercept is the plus or minus value in our slope-intercept form. That's our y-intercept, 0, -2. So if I were to go ahead and graph it, it would be very, very easy for me to go ahead and graph. I'm just going to come over to my graph, follow it down to where y is equal to -2, or 2 points down from the origin along the y-axis, and there's my y-intercept. Now, for the x-intercept, I just told you a very key and important thing about x-intercepts. I told you that the y value is always equal to what? 0. So what do you think that we're going to do with this y? If I just told you x-intercept is when y is equal to 0, what do you think I should do to the y? Make it a 0. If you want to solve for your x-intercept, change the y value to 0. That's how you can solve for your x. So for the x-intercept, you're going to plug in y equaling 0. We're going to replace the y as a 0 value. So we had y was equal to 2/3 x minus 2. We're going to replace this y with 0. And then we're going to solve like normal. 0 is equal to 2/3 x minus 2. Okay, it's just an equation, a two-step equation. First step is always to get rid of our constant. To get rid of our constant, we're going to go ahead, and I'm just going to use different colors for right now. We're going to go ahead and add 2 to both sides so that I can start isolating that value of x. 0 plus 2 is going to give me a positive 2. So I now have positive 2 is equal to 2/3 x. To get x by itself, right now this is showcasing multiplication. So what is the inverse of multiplication? Division. So I'm going to divide both sides by 2/3. Now keep in mind, we did not cover over the rules of fractions and how to work out multiplying or dividing because that was something from 6th grade. However, there's a possibility that on milestones, the non-calculator portions might have you working out a problem like this without the calculator. If you had to do, so this is a little subnote, if you did 2 divided by 2/3, This is the same thing as 2 times the reciprocal, 3 over 2. That's all. Reciprocal is just when you flip your fraction upside down. Okay? So if you had 2 times 3 over 2, that would come out to 3. Okay, so here we would get that x is equal to 3. So that means our x-intercept is going to get graphed at the point 3, comma 0. So we'd go back up to our graph. We're not going to move anywhere up and down. We're only going to be moving either left or right. In this case, we're moving right. 1, 2, 3. Crossing over the x-axis, and there's our 2 points. We can connect and we're done. Okay? All right, I want you guys to go ahead and flip over to the next page. I want you to try that one on your own. The example number 2. You're going to try example number 2 on your own. You're going to identify your y-intercept and your x-intercept, and then you're going to graph them. So, first things first, easiest thing to identify was your y-intercept. Y-intercept was a positive 5. Then we have to solve for our x-intercept. Remember, we replaced the y with a 0. Because when we're solving for x-intercept, it's when y is equal to 0. So we have 0 is equal to negative half x plus 5. We would then subtract 5 from both sides. That would give us negative 5 is equal to negative half x. We would then divide both sides by negative half. Okay, you will have your calculator with you at this time, but in case you ever come across where you don't have a calculator, negative 5 divided by negative half is the exact same thing as negative 5 times negative 2 over 1. So dividing by negative 1 over 2 is the same thing as timesing by negative 2 over 1. Okay? It's called a multiplicative inverse. Now, when you do negative 5 times negative 2, you get a positive 10. 10, 0 is your x-intercept. So if you were to graph those, 0, 5 is graphed here. 10, 0, graphed there. And then you would connect. Okay? Any questions? All right, when we come back from lunch, that's okay. All right, let's go ahead and move on. We're going to now get into what we're going to call standard form. So you saw the format here already. This is called standard form, but the basic abbreviation or setup of it is that you have the format of A x plus by is equal to c. Ax plus by is equal to c, where a, b, and c are all real numbers. They are all real numbers. X and y are your variables. A, b, and c are going to represent real numbers. The x and the y are going to stand for your variables. So here, the 4 represents our A, the negative 3 represents our B, the 24 represents our C. So we're going to be understanding or talking about how to identify x and y intercepts when they're in standard form. You do not need to rewrite. Standard form is actually the easiest way to be able to identify your x and y intercepts. So when they're asking you to do graphing, if it's in this format, you want to leave it in this format and just solve for your x and y intercept automatically. Okay, because it's a very simple process. So the first thing that I'm going to recommend is just go ahead and divide this little section up into 2 parts. And we're going to rewrite the formula twice. We're going to have 4x minus the 3y is equal to 24. And 4x minus 3y is equal to 24. The only reason I'm having you write it twice is because you're solving for 2 separate things. You're solving for an x-intercept, you're solving for a y-intercept. When you are solving for your x-intercept, we know that y is equal to 0. When we're solving for our x-intercept, we know that y is going to be equal to 0. So if I change this y to a 0, what happens to negative 3y? What does it become? Hassan? 0. So 0, if this becomes 0, it's as if it never even existed. Ooh, look at that. We just have a single step equation to solve then. So when you are solving in standard form and you're wanting to solve for your x and y intercepts, you're going to focus on your x term is equal to c, and then your y term is equal to c. And then you're done. You solve that way. So for here, all we would have to do is divide both sides by 4, and we would get that x is equal to 6. So there's the point that we're going to be graphing, 6, 0. And then we do the same thing for the y. For our y-intercept, that means that x is going to be equal to 0. So if this x becomes a 0, it's as if that 4x never even existed. So we're left with negative 3y is equal to 24. And then we would just solve. We would divide both sides by negative 3. And we would get that y is equal to negative 8. There's our point. We'd have 0, negative 8. Very easy process. Again, you've got your standard form. When you're solving for your intercepts in standard form, if you're solving for your x-intercept, you just set the x term equal to c. When you're solving for your y-intercept, you just set the y term equal to c. The only thing that I would say is the mistake that students make is that they tend to forget to include their minus sign as a negative sign when it exists. So just be mindful of that, okay? Then graphing. You just graph your two intercepts and connect to make your line. So it's really easy and quick. Agreed or disagreed? Agreed? Okay. Okay, so there's our x-intercept is down here at negative 8. Our y-intercept is over here, or sorry, our y-intercept is at negative 8. Our x-intercept is over here at positive 6. And then we can connect. Raise your hand if you need me to do another example. And it's okay if you do. I'm perfectly happy doing one with you. Everybody seems okay? All right, then what I want you guys to do is go ahead and try example 4, 5, and 6 on your own. They're quick. They shouldn't take you too long because they're just a really fast process. Examples 4, 5, and 6 on your own. I'll leave this one up here for you to see. So for problem number 4, who can tell me what they got for the x-intercept for number 4? David? Negative 2. Very good. What about the y-intercept? What was the y-intercept, Lucas? Negative 5. Very good. Okay, so this is what it should look like when you're solving it out. Remember that with solving for the x, the y disappears. When you're solving for the y, the x disappears. And then you just solve the one-step equation. So you get negative 2 for your x value, negative 5 for your y value. Remember, these are separate points. I've had people in the past think that they're together creating one single order pair, and it's not. It's negative 2, 0, and 0, negative 5. And that's what it should look like when it's graphed. Okay? What about for problem number 5? Problem number 5. Who can raise their hand and tell me what they got for the x-intercept? Richard? 2. Positive 2. And then the y-intercept, Montserrat? Positive 4. Very good. So here's what our, sorry, let's put that down real quick. Here's what our solution is going to look like when we are solving it. You're going to get 2, 0 for your x-intercept and 0, 4 for your y-intercept. And then, of course, you would graph accordingly. This is what the graph would look like. Go ahead and put this back up here. And then let's go over the last one, number 6. What is the x-intercept going to be? Isabel? Huh? Negative 6. And then Henry, what's the y-intercept? 9. Okay, so here's what that would look like. Any questions? It's pretty easy, right? It's about time that we got into something a little bit simpler. So we are going to, I know that there is a question here on the back. I'm going to go ahead and skip that for time purposes because we only have about 13 minutes left in class. And I would like for you to be able to get on, or actually less than 13 minutes. We've got only 8 minutes because I forgot you have to be at Connections at 12:45. So we are going to go ahead and you've got a quizzes today. You get one shot. One shot. one shot. It's due tomorrow. But